Greetings to all of you. The session is regarding the chemistry, which will be helpful for your intermediate section that will be fetching for international entrance and competitive exams as well. India is conducting JEE Advanced, JEE NEET Chemistry for medical entrance examination, JEE Advanced and JEE Mains question paper for entrance into IIT and NIT stream, right? So this will be conducted twice a year and will be fetching for the admission into IIT and NIT across the nation. And NEET chemistry for medical entrance examination conducted common to all the aspirants throughout India. And moreover, Telangana government, Andhra Pradesh government are conducting MSET examination, which will be fetching for the admission into BTech stream, that is the technical domain. In addition, government organizations are conducting most of the exams in different domains that are included with so many kind of fields, and the common question paper will be accorded, which covering with the general studies question paper, and one more will be there that will be relevant to their specified domain, but one of the common paper called general studies will be there. In that, general science content will be given. The session what we are discussing will be very much helpful for that kind of serious preparation. Let's enter into our today's session. Explain the name of coordination complex as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Iron, Cl, CO taken twice, NH3 taken thrice plus 2. This is the complex provided where iron is the metal and chlorocarbonyl ammonia are the ligands. Then how can we assign the name for this cationic complex? In order to accord the name for this one, here in accordance with the alphabetical order, we have to go for among chlorocarbonyl and this ammonia. A comes first over chloro and carbonyl. So that let me mention triamine. So it is mentioned as a triamine. Next, after mentioning A, we will go for C. In that C, we have ambiguity between two C's because the carbonyl comes with C, chloro comes with C again. Then among these two, carbonyl means we have to go for Ca. Then chloro means CH. Among these two, Ca will get higher priority over CH. That's the reason why. Let me write triamino dicarbonyl. So this is given as a triamine dicarbonyl. Next, how many chloro are there? One. So that need not to mention mono. Let's write chloro as simple as possible, right? So here triamine dicarbonyl chloro. Then if you want to write a central metal, now after writing all the ligands, only central metal mentioned, the central metal to be accorded with the oxidation state in the Roman numerals. So if the compound, if you observe the compound where we have chloro and plus 2 charge is there, that's why entire charge will become 3. That 3 can be mentioned in the Roman numerals, iron 3. So iron 3 ion. Iron 3 ion, being it is the charged one, definitely we have to mention suffix as a ion. Let me give the entire name of the compound as per the IUPAC protocol. Triamine dicarbonyl chloro iron 3 ion. This is the way IUPAC nomenclature will be provided, and always central metal should be accompanied by the oxidation state in the Roman numerals, right? So this is the way the compound can be named as per the IUPAC protocol. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Which of the following salt is insoluble in water? This is a kind of physical test. There are certain identification tests will be there called physical test, chemical test, flame test, different categorization in order to go for the analysis of the compound. If any compound you chosen that is unknown to you, so that we have to go for preliminary examination by physical test. Physical test is nothing but by seeing or by observing. If you are going to know something, that is called a physical test. Chemical test denotes by adding some chemical to another one, so that a chemical change will be occurred called a chemical change, right? So this is the way we can go for that solubility. Solubility means what? Take the salt, take the compound and add it with the water. So if you shake well, if you observe that one, you can analyze whether it is dissolving in water or else it is precipitated without any solubility. So that just by observing, if you are going to identify, that is said to be a physical test. So solubility test of the given salts with the water solvent. Water is a universal solvent. So that water is taken as a solvent and the salt, different salts are provided, among which is water soluble to be identified. So that different boxes are provided: barium sulfate, calcium carbonate, ammonium sulfate, iron 2 hydroxide. These many are provided, but among ammonium sulfate is of highly ionic substance, so that it is water soluble, can be taken with the right mark. Barium sulfate is highly covalent in nature, so that water insolubility will be there. Calcium carbonate is water insoluble. You can identify by means of taking chalk and make it into dust. Chalk dust will be dissolved in a water, so that you can identify milky white precipitate at the bottom. So it is water insoluble salt. Iron 2 hydroxide is sparingly soluble. If you are adding 1 gram, a minute quantity will be dissolved, remaining will be insoluble. So that sparingly soluble means some extent. Minute quantity water solubility is there, that is called partially soluble. And barium sulfate completely insoluble, calcium carbonate insoluble, ammonium sulfate well soluble salt in a water, being it is ionic substance. Ionic substance denotes what? Polar in nature. Ammonium sulfate denotes what? NH4 positive and SO4 minus 2 will be there. All the ions are highly specified, and ionic substance more favorable to dissolve in water. Water is being a polar solvent. Highly polar compounds will be preferred to dissolve in water. So that ammonium sulfate is more preferred for water solubility over barium sulfate, calcium carbonate, iron 2 hydroxide. Let's see in detail about all these. If barium sulfate is added with water, you can notice this. What does it indicates? Whenever you are getting a cloudy substance in the test tube, that indicates compound is water insoluble. It is not dissolved. If it is dissolved, you can get a clear solution. No particles are identified. It is readily visible. But barium sulfate added gives the cloudiness over the test tube, so that you can notice it is water insoluble. And calcium carbonate, when added to water, you can clearly notice that totally suspended at the bottom, precipitated at the bottom. It's very clear that it is 100% water insoluble substance. And go with ammonium sulfate. Ammonium sulfate, if added to water, what happens? You can clearly examine. Test tube is completely clear. It's so clear in nature, no precipitate is formed. Hence, you can identify it is water soluble in nature. Ammonium sulfate precipitate is common method. Protein purification, ionic strength of the solution increases. Solubility, ammonium sulfate is extremely soluble in water due to the ionic nature. It is salt out protein by precipitation. Because of its water solubility, it finds the applications in the laboratory use for protein purification. This is a kind of applicative phenomenon provided for ammonium sulfate, which is completely water soluble. You can get the clear solution. And go with iron 2 hydroxide. Iron 2 hydroxide is sparingly soluble. Sparingly means what? Minute quantities water dissolved, and else will remains like a cloudy substance in the test tube. You can clearly notice over here, so that we can say sparingly soluble in nature. This is the way all the solubilities got mentioned. Among all, ammonium sulfate is more prone for water dissolving substance. For question number 2, option number 3 is the correct answer. Move on to question number 3. Question number 3 collected from JEE Advanced 2017 question paper. Paper 1 question is: addition of excess of aqueous ammonia to the pink colored aqueous solution of metal, M for metal Cl2 6H2O. This is regarded as a compound X. And ammonium chloride gives the octahedral complex. You're adding ammonium chloride means amination process got carried. Again, it turned into octahedral complex. Why? In the presence of air. So air reaction, this is performed with In aqua solution, complex Y behaves as a 1:3 electrolyte. Complex Y is having 1:3 electrolyte, means one cation, three anions will be there. That is the way 1:3 electrolyte nature will be accorded. That means four ions will be present in that. The reaction of X with excess of HCl at room temperature results in the formation of blue colored complex. Blue colored complex is denoted with the compound Z. A calculated spin-only magnetic moment of X and Z both are same. X and Z both are having 3.87 Bohr magnetons. Bohr magneton is the unit of electromagnetic nature, and X and Z, both are having 3.87 indicates what? X compound, Z compound, both are having same number of unpaired electrons. In quantification, that is 3 in number. 3 unpaired electrons if present, spin-only magnetic moment will become 3.87. Okay, whereas it is 0 for complex Y. Complex Y is not exhibiting any magnetic moment, rather it's a magnetic moment value taken as 0. That indicates all the electrons are paired up. This is the way we got the so many hints over here, and accordingly we have to go for the solution part. So here four options are provided. Among our correct options are A, B and D. C is wrong one. Then let's see what are the correct options. Hybridization of the central metal Y is D2sp3. In case of complex Y, D2sp3 hybridization will be there. Z is a tetrahedral complex. Whatever Z is there, that Z is said to be a tetrahedral. Addition of silver nitrate to Y gives only two equivalents of silver chloride, they are saying. When Z and X and Z are equilibrium at 0 degrees, color of the solution is pink in color. When X and Z are both equilibrium, what happens? The color exhibited is pink. These are the kind of options provided, so that we have to find out the correct answer regarding this question. In order to get cobalt H2O taken, 6Cl2 will be taken. So this is the starting complex, whatever they mentioned, metal is there, unknown, Cl2, 6H2O. So that properly arranged in such a way, cobalt H2O taken, 6Cl2 will be there. Water is the kind of weak field ligand, and that is said to be high spin complex. Whenever high spin complex is there, all the electrons are not paired up, hence its magnetic moment is said to be 3.87, which exhibits a pink colored solution. Aqueous ammonia ammonium chloride mixture if taken and added with air, so that the complex is totally exchanged with the ligand, aquated complex now shifted to aminated complex. So here cobalt NH3 taken 6Cl3. The complex is hexamine complex. Here aqua complex now shifted to hexamine complex, where amines are strong field ligands called low spin complexes. Hence, magnetic moment value will become 0. And whatever starting material aquated cobalt complex is there, now treated with hydrochloric acid under excess quantity, and purely 0 degrees centigrade temperature to be maintained. At that condition, cobalt hexaquo now turned into cobalt tetrachloride, being chlorination carried over at a lower temperature. The cobalt tetrachloride complex will be formed and it is said to be tetrahedral, and its color will be blue. And here you can notice mu value as a 3.87 Bohr magnetons, being it is a kind of tetrahedral complex sp3 hybridization. In addition, you can find 3 unpaired electrons, so that 3.87 Bohr magnetons formed. Delta H is said to be positive. The value of delta H is enthol, means the reaction is exothermic. Whenever the hydrochloric acid is added, heat evolved during the reaction, being reaction carried at lower temperature. High temperature is excluded after the formation of product. So these are expected reactants and the products. Let's go with how to justify all the options whichever provide. Whenever you go with the cobalt hexaquo complex, already we aware that aqua is the weak field ligand. Always weak field ligand will not show electron pairing. Cobalt is atomic number 27, D7 configuration, and it is taken with the +2. Whenever +2 is there, remove 2 s electrons. 7 d electrons will be there. Let me arrange 1, 2, 3, 4, 5, 6, 7. D7 electrons will be arranged, and s orbital, p orbitals are empty in nature. Okay. So whenever this is the case, what happens? You can count the number of unpaired electrons are 3. Unpaired electrons are 3, so that under root n into n plus 2 value will be mu is equal to under root 15 Bohr magnetons. Under root 15 is equal to 3.87. 3 unpaired electrons giving 3.87 Bohr magnetons of magnetic moment value. This is the way they are saying. This is the way it is participating sp3d2. So here 4d orbitals will be there. 4d orbitals will participate in hybridization. sp3d2 outer sphere orbital contribution will be there, and we will get the complex like this. And if you go with hexamine, cobalt hexamine complex, if taken here, it is accompanied by the 7 electrons like this, but here oxidation state of the cobalt in this complex will be +3. If complex oxidation state is +3, if you see what happens, Cl3 is there. 3 chlorides means 3 negative charges compensated by 3 positive charges on the cobalt, so that a cobalt is acquiring +3 oxidation state over there. So being it is atomic number 27, valency shell configuration is 4s2 3d7, and in case of +3 oxidation state, 4s2 electrons removed, 3d7 one of the electron removed, so that it will become 3d6. 6 valency electrons can be arranged in such a way, so 5 plus 1, 6 electrons will be there. Under the presence of these strong ligands, strong field ligands, all the electrons got paired up. So whenever all the electrons paired up, 2 d orbitals and s orbital, p orbitals are empty. So here hybridization is carried d2 sp3, inner sphere configuration. d2 sp3 mentioned in option number 1. Hybridization of the central metal in Y is d2 sp3. Y means ammonia complex. After treating with ammonium chloride, this is turning into ammonia complex. That ammonia complex octahedral only, and being it is d2 sp3, so that we can say it is the inner sphere. This is called a inner sphere complex. So d2 sp3 hybridization will be there. If you go for calculation of magnetic moment will become 0. No unpaired electrons, so that no magnetic moment will be accorded. This is the way d2 sp3 is the correct one. Z is the tetrahedral. After getting the entire calculation, what we can notice, Z compound is made cobalt Cl4 minus 2. This cobalt Cl4 minus 2 is a kind of Z complex where you can find a tetrahedral geometry. How can we say tetrahedral geometry? Cobalt Cl4 minus 2 purely the kind of tetrahedral. You can clearly observe all chloride ligands are occupying tetrahedral corners. And you can clearly notice that chlorine is the weak field ligand end of high spin complex. So that cobalt minus 2, and here taken 4 is there. So that all 7 electrons remains in that, being it is +2. So whenever +2 is there, 1, 2, 3, 4, 5, 6, 7. +2 means s electrons we discarded, 7 d electrons remains. And chloro is weak field ligand, so that electrons remains as such. We are not supposed to pair it up. And all 4s and 4p orbitals are empty. 4s and 4t orbitals are empty. Therefore, 4p orbitals empty are combining to give sp3 hybridization. sp3 hybridization belongs to the tetrahedral geometry. This is the way tetrahedral geometry is given for the compound Z. So tetrahedral complex is the correct one only. Addition of silver nitrate to Y gives only 2 equivalents of silver chloride. This can be answered. Y compound is having cobalt NH3 taken 6 and Cl3. These 3 chlorides are called primary valency. Primary valency gives rise to its oxidation number, and secondary valency gives rise to its coordination number. Primary valency is nothing but the ions whichever present the outside of the sphere called primary valency. Inside of the sphere is called a secondary valency. Always a primary valency of the coordination complex giving oxidation number, and secondary valency of this coordination complex will give coordination number. So if you observe this, here three chloride ions are free. These can be ionized easily. Whenever three chloride ions are free for the donation, when silver nitrate is added, how many silver nitrate required? Each silver nitrate compensate one chloride. So the three silver nitrates are required, but they are saying only two. Here we can clearly notice three silver nitrates are required to compensate three chloride ions, so that you can replace like this. So three chlorides now replaced with nitrates, and basically we will get silver chloride as the white color precipitate. So, but within the option they mentioned that addition of silver nitrate to Y gives the two equivalents. Two equivalents is the wrong magnitude in the number. So the three equivalents of silver chloride will be formed because three chlorides are free. So option number C is wrong, so that it is not indicated with the tick mark. When X and Z are equilibrium at 0 degrees centigrade, color of the solution is pink. X and Z are in equilibrium. X means cobalt H2O taken 6 Cl2, and Z is cobalt Cl4 minus 2. Cobalt H2O 6 Cl2 is called pink color, and this cobalt Cl4 is the compound of blue color. When both the complexes are existing in equilibrium, when cobalt tetrachloride and cobalt hexaaqua are in equilibrium, what happens? So this indicates that cobalt chloride is blue in color, cobalt hexaaqua is pink in color. Whenever both are in equilibrium, always the reaction tends to move towards the forward direction. This is more favorable condition in comparison to the backward. That's the reason why most of the cases equilibrium laying towards right hand side, so that a compound exists in pink in color. Because of that reason, compound exists in pink in color, right? So this is the way we can answer this. When cobalt chloride and then increase its concentration within the system, equilibrium would initially turn much blue, therefore partial offset. So initially blue color will be existed. Upon addition of water, slowly the color changed to pink, and there is a backward direction is also possible, but maximum extent reaction will stay at right hand direction. That's the reason why, though both are in equilibrium, but color exhibited with the pink because of the existence of the product maximum extent over reactant substance. This is the way we can answer the option number 4, that is satisfying whatever we are reacting. So for question number 3, option number A, option number B, option number D are correct. C is wrong one. Let's move on to question number 4. Question number 4 collected from JEE Advanced 2018 question paper. Paper 1 it will be. These many compounds and ions provided, molecules and ions are provided. From that you need to identify a number of diamagnetic species. Only how many are diamagnetic to be numbered. Among hydrogen molecule, helium-2 plus ion, lithium-2, beryllium-2, boron-2, carbon-2, nitrogen-2, oxygen -1, fluorine. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 9 compounds or molecules, how many are said to be diamagnetic in nature to be identified? For our convenience, the data provided: hydrogen atomic number is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, and fluorine is 9. This is about atomic number, and this is about molecular formation. So that how many diamagnetic are there to be identified? It is mentioned as number 6. Among 9 molecules, 6 are said to be diamagnetic in nature. Let's go with how can we answer. The correct answer is hydrogen, lithium, beryllium, carbon, nitrogen, fluorine. Molecules are said to be diamagnetic in nature. However, beryllium 2 is actually in practical sense diamagnetic only, but certain extent of magnetic nature exhibited, that is because of s orbital p orbital overlapping. That is exceptional, so that it can be regarded as 5, but in practical sense we have to put on 6 is the correct answer. Move on to hydrogen. Hydrogen molecule, if taken into the consideration, simplest molecule among all, each hydrogen contributes only one electron. Hydrogen is accompanied by 1s1 configuration. 2 electrons are accompanied with the 1s1 configuration, so that let's combine two electrons to give sigma 1s orbital. Sigma 1s bonding orbital will be there, so that if you observe electrons got paired up, so that it is a part of diamagnetic. Diamagnetic nature is accorded for paired electrons. Parallel electrons are contributed for magnetic paramagnetic nature, so that we can say hydrogen molecule is diamagnetic in nature. Move on to helium 2 plus. If you go with helium 2 plus, helium 1s orbital is having two electrons, and 1s orbital of helium plus is having one electron only. Helium is of atomic number 2. It is the noble gas. Always 1s2 will be there for one helium atom, and 1s1 will be there for helium plus. Okay, one side you can take helium atom, another side you can take helium plus ion. If you clearly observe, it is clear to you. Then three electrons are contributed in such a way. Sigma 1s orbital is having two electrons. Sigma star 1s orbital is having one electron. The star 1s orbital electron contributed for paramagnetic nature. This is paramagnetic in nature because of one odd electron is there. Move on to next one, lithium molecule. Lithium is of atomic number 3. 3 electrons, 1s2, 2s1 electrons will be there for one lithium. Second lithium also having 1s2, 2s1 electron. So here 3 plus 3, 6 electrons are contributed like this. 6 electrons, 2 electrons in bonding, 2 electrons anti-bonding, 2 electrons bonding. If you observe, all the electrons after the molecular orbital formation got paired up, you can clearly observe it is of diamagnetic, being all the electrons are not free. So the diamagnetic in nature. Second compound you unveiled. Then beryllium molecule formation. Beryllium molecule is formed by combining two beryllium atoms. Atomic number of beryllium is of 4. 4 is contributed with 1s2 and 2s2. 1s orbital accompanied with 2 electrons, 2s also 2 electrons. So that 1s electrons will be occupying sigma 1s and sigma star 1s. 2s orbitals electrons, 4 electrons are contributed in 2s bonding and 2s star orbital, so that all the electrons got paired up. It is also very clear diamagnetic in nature. Beryllium 2 is also diamagnetic in nature. Move on to carbon molecule. Carbon molecule is accompanied with the 1s2, 2s2, 2p2. Being atomic number is 6, 1s2, 2s2, 2p2 you can go with, so that you can identify two electrons bonding to antibonding to bonding to antibonding will be there. So here 4 electrons are arranged in such a way, 1, 2, 3, 4. So these two unpaired electrons are more prominent for the paramagnetic nature, so that this C2 is said to be paramagnetic in nature. Move on to nitrogen. Nitrogen molecule is made up of 2s2, 2p3, 2s2, 2p3. So the 2, 2, 2, 2, 2. All the 6 electrons arranged in such a manner, what pi 2py, pi 2px, pi 2py, sigma 2pz. These are orbitals which are accompanied with the 6 electrons. So no odd electrons are observed. We can say diamagnetic in nature. Oxygen minus. O2 minus means one of the oxygen is having 1s2, 2s2, 2p4. And second oxygen is having 1s2, 2s2, 2p5. One electron extra. One electron extra indicated with the negative charge. Okay. One oxygen atom is having 1s2, 2s2, 2p4. Second oxygen minus, O minus is having 1s2, 2s2, 2p5. Okay. This kind of arrangement, if you see, 2s2, 2s2 electrons are arranged in sigma bonding, anti-bonding finished up. And 2p orbital, we have 4 electrons one side, 5 electrons one side. 5 plus 4, 9 electrons to be accommodated. 2, 4, 6, 7, 8, 9 electrons are arranged in such a manner. One of the odd electron will remains, and this odd electron accounts for its paramagnetic nature. This odd electron is for paramagnetic nature. This is the way you can mention. And go with fluorine. Fluorine is the molecule. If you go with 2s orbital, 2 plus 2 electrons, 2 electrons into sigma bonding, 2 electrons into sigma anti-bonding orbital. And if you go with 2p orbitals of 2 fluorines, 5 electrons and 5. 5 plus 5, 10 electrons are arranged. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons are arranged like this in the fluorine molecule. Okay, 10 electrons are arranged, all the electrons are paired up. When all the electrons are paired up, it is said to be diamagnetic in nature. It is called a diamagnetic compound. Fluorine is the diamagnetic compound. By this, we completed the entire one. Let me repeat once again. Hydrogen is diamagnetic, lithium 2 is diamagnetic, beryllium 2 is diamagnetic, carbon 2 is diamagnetic, nitrogen 2 is diamagnetic, fluorine 2 is also diamagnetic in nature. So if you count all these, 6 is the number where you can go for 6 is the number. For question number 4B is the correct option. Move on to question number 5. Question number 5 is collected from Telangana MCET examination. The difference conducted in the year 2022. The difference in the wavelength between the maximum and the minimum Balmer series use Rydberg constant value 1 into 10 to the power 7 meter inverse. Okay, maximum and minimum Balmer series wavelength, difference between the wavelength to be understood. Okay, Rydberg constant value is given over here. The difference in the wavelength value is given as a 3200 angstroms. 3200 angstroms to be calculated. How can we go with? In order to calculate, always energy is reciprocal of wavelength. Means energy is inversely proportional to wavelength. If you give the equation energy proportional to 1 by lambda. Lambda max, if you go with the Balmer series, and this series of lines occurred like Lyman series, Balmer, Passion, Bracket, Fund, all these series based on the ground state level. If n is equal to 1, that is called Lyman series. N is equal to 2 is the ground state, that is called Balmer series, which occurred in the visible region. Balmer series is the one which occurred in the visible region. So here Balmer series started with n1 is equal to 2, and higher levels will be next onwards 3, 4, 5, 6, and up to infinite value that will be proceeded. But only the thing we need to understand is the lowest level is 2 only. Balmer series starts with 2. Okay, wherever the energy is laying, if it is come back to the ground state 2, that is accorded in the Balmer series and accounted for the visible light. For lambda max calculation, the transition of lowest energy means highest wavelength. Lowest energy is accorded when the electron is jumping from ground state. Balmer is 2, no, jumping from this 2 to next level only one step it is moving, so that energy requirement is low. Everybody aware that if you want to walk for only one stair, that is somewhat easy, less energy is consumed. If you want to walk for 5 stairs of building, what happens? Your energy maximum consumed, right? So maximum energy we need to invest. That means what? N is equal to 2 to 3 means only one level you are exciting. Only one level excitation requires extremely less amount of energy, so that longer wavelength can be noticed for this one. Less energy, longer wavelength, 2 to 3. Only one step you are moving. But lambda, highest energy, lambda value will be minimum, because energy and wavelength both are inversely proportional. Whenever lambda minimum, energy will be highest. Highest energy is possible whenever electron is moving from second level to infinite level, 100th level, for example, 1000th level, whatever it kind of be. Infinity means we can't count, we can't reach the number. That will give the highest energy gap and lowest wavelength. These two possibilities we have. In general, the formula for the lambda calculation, wavelength calculation, in accordance with this, in accordance with the Rydberg constant, is given by 1 by lambda is equal to R into 1 by n1 square minus n2 square. 1 by n2 square can be taken. If you calculate for lambda max means larger lambda value. 1 by lambda max is equal to Rydberg constant R into, in case of lambda max, n1 value is, ground state is 2, no? So that 1 by 2 square minus highest level will be 3, because lowest energy is required whenever one step excitation. So 1 by 3 square can be taken. If you write for this, 1 by lambda max is equal to R 1 by 4 minus 1 by 9. This will be written as 1 by lambda max is equal to 5R by 36. Lambda max, if you take this denominator to numerator part, the entire equation will be reciprocated, reversed. Then lambda max is equal to 36 by 5R. This is the way you can write 36 by 5R. This is one of the value. Go with the lambda minimum. 1 by lambda minimum is equal to R 1 by starting level. For all Balmer series, starting level will be 2 only. So that 1 by 2 square minus highest level is lambda, infinity, because highest energy is required for infinity level if you are jumping to. So that 1 by infinity square. Always 1 by infinity square ratio can be taken as 0. So that the value will become R into 1 by 2 square means 4. R into 1 means R by 4. R by 4 is the value for 1 by lambda minimum. Then lambda minimum, you are taking this lambda minimum up, so that equation will be reversed and you will get lambda minimum is equal to 4 by R, where R is the Rydberg constant whose value is known to you, 1 into 10 to the power 7 meter inverse. If this is the calculation of lambda max and lambda minimum, then you have to go for, they're asking for difference in the wavelength. So difference in the wavelength is calculated in such a way. The difference in the wavelength is equal to lambda 2 minus lambda 1. Lambda 2 value is 36 by 5 R minus lambda 1 value is 4 by R. Okay, lambda max minus lambda minimum. If you take the difference, 36 by 5, the value is 7.2 by R remains like that, minus 4 by R. Okay, 7.2 minus 4, the value will be 3.2. Then R is known to you, that is 1 into 10 to the power minus 7, and entire value present in meters. Okay, entire value is present in meters. If you want to convert meters into angstroms, 1 meter is equal to 10 to the power 10 angstroms. Okay, so that is the way. If you take this denominator value up, then it will be 3.2 into 10 to the power 7. 3.2 into 10 to the power 7 it will be. So 3.2 into 10 to the power 7 can be written as 3200 into 10 to the power 10. 3200 into 10 to the power 10 meters is equal to 3200 angstroms. Okay, 3200 angstroms we got. So that is the way meters can be converted into angstrom. So for question number 5, option number 2 is the correct answer. Move on to question number 6. Question number 6, what is the effect of external pressure on the osmotic pressure of the solution? If external pressure is applied, what is the change in the osmotic pressure value? Osmotic pressure decreases with increasing the pressure. Osmotic pressure decreases initially, then increases. Osmotic pressure remains nearly same with increase or decreasing the external pressure. That indicates what? Independent of the external pressure. Osmotic pressure increases with increasing the external pressure. Among all, the correct answer is osmotic pressure remained nearly same with increase or decreasing the external pressure. Why? Osmotic pressure, if considered, osmotic pressure means what the minimum pressure which needs to be applied to the solution to prevent the inward flow of its pure solvent across the semi-permeable membrane. Pure solvent one side and solution was taken on the another side, and both are taken partition by the semi-permeable membrane. What semi-permeable membrane will do? The semi-permeable membrane, what osmotic pressure will do? Osmotic pressure is the minimum pressure which needs to be applied to the solution. Towards the solution you can apply, and which used to prevent the flow of a solvent into the pure solution, into the pure solvent through the semi-permeable membrane. It will retard the movement. Osmotic pressure will retard the movement of solvent flow, right? So that is the way you can go for solution molecules are not moving into solvent molecules by this osmotic pressure property. Whenever external pressure is applied, here you can notice external pressure is applied, then aquatic pressure is not affected and both the levels are existing in the equilibrium. Even external pressure is increased or decreased, osmotic pressure will not be changed. It remains equilibrium. It remains the same. That is mentioned in the option number 3. For question number 6, option number 3 is the correct answer. By this, we entirely completed the session where different domains, different corners of chemistry got taken into the overview. And this session is really informative, and moreover, detailed, authentic information is provided, which is collected from the specified databases. And hopefully, this whenever you are going to observe the session very clearly and seriously and taking the notes from this one, definitely you can achieve whatever questions are given in the examination, because these are the questions which are repeated for so many times in the previous examinations. Very important concepts are taken into the consideration. Hence, if you are seriously preparing for the exams, the session is 100% helpful. I'll assure for that. That's why I'm sincerely requesting you to like the channel. And there is a question for comment for the session. If you go for different series of lines in the hydrogen spectrum, likely one is said to be Lyman series, Balmer series, Paschen series, Brackett series, and Fund series. Among these many type of series, what are the ground level energies and what are the level of that means segment of electromagnetic radiation observed? I'm giving the hint for you. Balmer series observed in the visible region. In the same way, where the Lyman series occurred, where the Brackett series, where the Paschen, where the Fund series. So this is the way you can go for two questions to be answered for the session. One is if you're going with the different series of lines. Lyman series, what is the ground state? Balmer series, ground state. Passion, bracket, fund, all these ground state energy levels to be mentioned. That is question number 1. And if you go with the different series of lines, where the Lyman series occurred, where Balmer series, where passion, bracket, fund series occurred. So two questions to be answered, and they are posted via comment box only. You can give your answers. Okay. uh, I'm requesting you to share this content with all the aspiring students who are very serious about the examination. For sure, they will crack the exam, whatever serious about the chemistry examination, if such kind of sessions are seriously followed. And subscribe the channel to achieve more updates in the near future. Thank you for watching. Thank you, one and all.